I think it started now, and I want to start by thanking you, the Committee of International Organization of Psychophysiology, for accepting this presentation as an oral presentation, because this is my first one and I'm very excited to do this, and a little bit sad as well because we are not doing this together face to face, so that goes on there as well, but I'm still grateful and I will try to make my best in the following 5 minutes, and I hope I'm going to be clear enough for you. Before I do that, I want to go over the title and explain 3 important concepts that I have in this presentation, and one of them is brain oscillations, and the other one is older adults, which means healthy aging, and the third one is stable perception experiment. So the main idea of this presentation is going to be what happens to the brain oscillations when we age in a stable perception experiment. So that's the idea. And I'm going to start by explaining what stable perception is, and it's a study of ambiguous figures, and these figures have special properties, and one of them is that they are physically unchanging. It could be a pattern that is going on repeatedly, it's the same pattern over and over again. As you see on the left, it's called an SAM figure. Okay, but the thing is, even though the patterns are not changing, but our brains generate multiple perceptual interpretations from this one pattern or one image. So if you observe this kinds of figure long enough, you are going to experience perceptual reversals from one interpretation to the other one, and it's going to reverse to the first one again, and it's going to go on and on again if you observe them long enough. So I'm going to try to show you 2 of the interpretations of this figure, and one of them is vertical motion of the dots. Okay, most of you probably have seen this when I first show you this, and the other one is horizontal dot motion, like that. So if you observe this figure long enough, you're going to see these dots move up and down and then horizontally over and over again. So what happens with aging is that after the ages of 55 to 60, we observe significant decreases in perceptual reversal rates. In other words, speed of reversals decrease significantly around the ages of 55. And what we wanted to do is to find out what are the oscillatory correlates of this age-related decrease in reversal rates. So we have chosen 2 of the oscillations, and one of them is theta band, and this is related to the top-down resolution of perceptual ambiguity. And this is observed primarily at the right frontal location and right central location, and the function is thought to be to send the triggering signal to the posterior areas and help to resolve the perceptual ambiguity that is arising from this multiple perceptual interpretations. And the other one, the other oscillation, is alpha band. And this band is considered to have a little bit more of a passive process, and it's thought to maintain the perceptual interpretations in a given area. And in young adults, it's occipital and parietal cortex. And what we observe in alpha band is a gradual decrease in the synchronization of alpha activity. So we conceptualize that as the destabilization of the perceptual interpretation. So it's going down, 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 and after a critical threshold, we assume that perceptual reversals happen and it stabilizes again. What we found in theta activity was an attenuation of frontal and central locations. So if you remember the functioning of theta, and it was related to top-down modulation of perceptual ambiguity, and it was helping us to reverse the interpretations. So we are finding a deficit here in older adults. And there are some similarities between this and working memory deficits and theta activity in aging. It is a little bit of a stretch at the moment, but I think if we investigate it further with new experiments, we can find something interesting between these relationships. There might be a shared mechanism between them. And the other finding was concerning the alpha activity, and with aging, we see a complete topographical shift of alpha desynchronization. So additional alpha networks were recruited to represent the perceptual interpretations, and all of these networks from all over the cortex has desynchronized up until to the reversal. And this has been actually shown in simple sensory experiments as well, even in middle-aged adults. The occipital alpha response that we usually get in a sensory stimulation was shifted towards the anterior locations. So I think this is an echo of that same thing, same compensation mechanism. So overall, what we are seeing here is increased bottom-up representation of the perceptual interpretation, and decreased top-down resolutions of them. And that is all for now. I hope to see you in future, and thank you for your attention.